Students, we are back for 9.4, which is area and perimeter on a coordinate plane. We just spent a whole bunch of time on area and perimeter of 2D shapes, and today we're going to talk about what that's going to look like on the coordinate plane, or when points are given to us. So I actually have two drawings here. Both of them are given to us. We didn't actually have to plot them. And I just want to take a second to kind of review what we're going to be talking about a little bit. I have these two printed out, and I'm going to put a copy of this on Schoology if you'd like to print it out. But quite honestly, I think you could just spend the next 2 minutes just kind of listening in, paying attention, and working on the assignment on your own. I don't necessarily feel like all of you will want or need a copy of these notes, because I'm just going to explain what to do for these. If you have a shape on the coordinate plane, you are looking for the perimeter and you are looking for the area, and we'll actually only look for the area down here. You can easily find the perimeter. It's just not something we're going to talk about right away. So in order to find the perimeter, we need the side lengths of everything. Oftentimes they're given to us. They're not written given to us, but we can simply count. If it's horizontal or vertical, we just can count to figure out what the distances are there. For a side like this, though, that's not given to us, or something that we can't count, we can use the Pythagorean theorem. So let's do that. There's this little tiny triangle with a height of 4 and a base of 2, so 4 squared and 2 squared is equal to x squared. And that value is 4.47 when you follow through with that and plug it in your calculator. So the perimeter is the easy one. The perimeter is everything is added up. Plug that all in your calculator, 18.47. I'm going to use units. I mean, technically, because it's on a coordinate plane, you wouldn't necessarily need anything, but that's the perimeter. Hopefully you feel comfortable with that. The area, in this case, you could find the area of the square and find the area of the triangle, totally fine. You can use some composite figures. I'm going to use the area formula for a trapezoid, because I know it's a trapezoid. It has one set of parallel sides, two parallel sides. The area is 1/2 base 1 plus base 2 is equal to the height. Kind of plug in everything we know. The two bases are the two sides that are parallel, so that's 4 and 6, and then the height that's given to us. So we could have done all the area without the Pythagorean theorem. Plug that all in your calculator, and you get 20 units squared, and squared because it's area. So I'm hoping that if I would have given you enough time or some time on your own to figure that out, you probably could have done that on your own. Let's look at a problem like this one down here. Now I'm hoping if you don't have this printed out, you're kind of taking a second to look at this, figuring out, okay, could I find like the area of this triangle and then the area of that triangle and then the area of that triangle and like the area of that. I mean, you would not be wrong, but I'm telling you that there's an easier way. Technically, you could do it that way. What I prefer to do with irregular shapes that I can't just use like the triangle formula on, or I can't just use the trapezoid area on, I want to use some composite figuring here, and we're going to use a subtraction composite problem. So I'm going to find a regular shape. I'm going to find a rectangle. It's probably the best bet for us. A rectangle that fits this shape within it. Because if I can find the area of the rectangle and then subtract all of these triangles outside of it, that's going to be the easiest way to do this. Are there other ways? Yes. Is this the easiest way? Yes. So I'm going to kind of set some stuff up here. For example, the area of the rectangle. The whole rectangle is 7 by 8. I should have wrote that down. 7 by 8. And that area then is 56. And I'm going to subtract all of these triangles. I'm going to use some different colors here. All right. So this triangle here is 3 by 3 is your base and your height. So 1/2 3 times 3 is 4.5. So we got to subtract out that triangle from the whole rectangle. All right, this one is 4 and 2. 1/2, 4 and 2. That's 4. This is 6 and 5. 1/2, 6, and 5 is 15. Oh, I forgot to write that in there. And lastly, this one is 5 and 2, so 1/2 base times height is 5. At that point, you have your square. You're subtracting all of those triangles. Plug that in your calculator, and your final area is 27.5 units squared.